Design and fabrication of semi-automated drainage cleaning system. Abstract. The research paper focuses on replacing the manual method of cleaning the drainage system with the semi-automated mechanical drainage cleaner. The method followed nowadays is proving to be the health hazard for the worker undergoing the process of cleaning the drainage. Along with the drainage water, some solid waste travels through the drainage line, and at the junction points of drainage system these solid waste gets accumulated over time and thus causes the blockage of system. This urges the need of timely cleaning of drainage lines. So this system will help to resolve the problem and will thus help in ensuring the timely cleaning of the system by segregating the solid waste. Keywords: drainage system, solid waste, manual cleaning, health hazard. Introduction. Water running through a water drainage system usually carries along waste materials, most of which are non-biodegradable, which not only cause flooding but also climate change. Overflow of drainage water through drainage system occurs when there is a blockage at an end of the drainage system, forcing the water to find its way elsewhere apart from the mapped-out drainage system. Therefore the running water spills over the horizontal height of the drainage system, spreading to regions alongside the drainage system, thereby causing problems such as pushing down of structures such as fences, water logging of farmlands and residential buildings, etc. 1. Drainage systems are blocked most times by garbage like nylon, plastic bottles, and empty cans, which cluster together and find their way into the drainage systems. If this garbage is allowed to flow, it blocks the system, due to which water flow gets distracted and it comes out of the drainage cover too. The method followed nowadays to clear these blockages are either by using suction machine, which is a costly method way, or else by road sweeper, an unskilled worker who has to enter the drainage hole and clean it manually, which is dangerous for their health. The drainage systems are cleaned when there is no water in them, i.e. when it is not raining. But when it is raining, the drainage systems cannot be cleaned because of the severe conditions of the rain, which no one would volunteer to endure to ensure garbage does not enter into the drainage systems. 3. These solid waste, separated either by suction machine or manually, are not properly disposed. They are allowed to litter in the nearby areas. Also, non-uniform size of the drainage lines is one of the major issues for designing a universal cleaning machine. 4. 2. Literature review. Author. Research. Remark / End by C. Daniels. 2014. Drainage System Cleaner, a solution to environment hazards. Developed a system that works on the flow of drainage line. R. Sathyakalab P. Maheswari. 2012. Smart Sewage Cleaning System is the automatic functional network using smart arm extraction and e-bucket heating. Worked on the smart arm that can lift and be used for extraction of the blockages. Xiao Zhang. 2016. Drainage cleaning using ceramic filter. Ceramic filter is used to clean the drainage system. Balachandra.g. Kartikeyan.s. Divya.n. 2016. Semi-automatic drain for sewage water treatment of floating materials. Since the paper studied and designed the system for only uniform drainage line and holes, it lagged the study of non-uniform drainage hole. 3 objectives. The major objectives of the project are as follows. 1. Basic safety of the labor and hygiene. 2. To replace the manual system by semi-automated system. 3. The system should be portable. 4. The system should be able to segregate solid waste from the drainage water. 4. Methodology. Fig. 1, Methodology. Capture. V. System design and working. DCM consists of various parts, which includes motor, chain and sprocket, belt and pulley, shaft, collector, and lifter. Once the power is supplied to the motor, the output shaft of motor starts rotating. The main shaft and output shaft of motor is connected with the help of belt and pulley arrangement. Chain and sprocket is mounted on the main shaft, and the lifter bucket is mounted on the chain. Once the chain starts rotating, the lifter starts moving along with it. 5. All the solid waste, including plastic bottles, cans, carry bags, etc., gets lifted up through this bucket and it is collected in the collector. 1. Frame calculations. Fig. 2, Frame dimensions. Assuming water pressure on frame is 2000 kg/m superscript 3. P equals 2000 kg/m superscript 3. As its pressure limit is 5 kgf/cm superscript 2, which is greater than calculated pressure 0.001034 kgf/cm superscript 2. 2. Calculation for base frame. Assumptions. Total load on frame is about 10 kg. ASME code for design of shaft. Since the loads on most shafts in connected machinery are not constant, it is necessary to make proper allowance for harmful effects of load fluctuation. According to ASME code, permissible values of shear stress may be calculated from various relations. As, actual, is less than, allowable. Input shaft is safe under torsional load. Hence we select shaft with diameter of 20 mm. 6. Calculation of bearing. Bearing selection completely depends on shaft diameter. Here we have selected the perfectly safe shaft of diameter 20 mm. Since the shaft is of diameter 20 mm, so we have used the bearing of 20 mm ID. The bearing number 204 pedestal bearing is used because it is self-aligned bearing. Material selection. Frame. Frame is the crucial part of machine. All the forces, stresses and water pressure are calculated. After studying the results of calculations, we have decided to use GCI-15 material for fabricating the main frame as well as the base frame of the machine. 6. Motor. The main purpose of motor is to convert electrical energy into mechanical energy. There are two types of motor, viz. 1. AC motor and 2. DC motor. Our requirement of speed is not more than 30 rpm and power not more than 70 watts. This is satisfied by 1.2 volts and 7 amp wiper motor. Shaft. Shaft is the rotating element used to transmit the power. We will be using solid shaft. The shaft should have high strength, good machinability, high wear resistance and good heat treatment properties. The materials used for shaft are carbon steels of grade 40C8, 15C8, 50C4, 50C12. MS and EN8 can also be used. We have selected 15C8 for shaft. Bearing. The shaft diameter is 20 mm. Therefore the ID of bearing needs to be 20 mm. From the calculations we have decided to use RB204 pedestal bearing. Pedestal is nothing but the plumbing block. It is used to provide support for rotating shaft with the help of compatible bearing. Chain and sprocket. We have used pintle chain and 6-inch sprocket. As per the standards available in the market satisfying our requirement. 6. CAD model. 7. Fabrication. During fabrication, firstly the base frame was welded according to the dimensions and then the remaining pipes were welded on the base frame. After making the frame, pedestal bearings were mounted on the frame and then the shafts of required diameter were engaged in the bearings. Also the chain and sprockets were mounted on the upper and lower shaft. Sheet metal and the net were welded on the front-facing frame pipes. Lifter was prepared from the net-like pipes. Also the collector bin was prepared separately. It was provided with the handle to lift. Meanwhile the side flaps were created and mounted on the side pipes of the frame. Also the wiper motor was mounted on the position and by using belt and pulley arrangement drive was provided to the driving shaft. 8. Testing. Testing of the final project was conducted by nearby water reservoir. The side flaps provided were properly working and helped the water to pass through the net only. The lifters were able to lift maximum weight of 4 kg at a time. The solid waste lifted by lifter was properly disposed in the collector bin during each rotation. 9. Advantages. System works properly at given conditions and it is to be the most economical way of cleaning. Easy to operate as no special skills are required. Reduction of labor-oriented method of cleaning, thus upgrading the dignity of labor. System is light in weight and easily portable. Efficient for residual removal. Large amount of garbage will be collected, which can be recycled. Conclusion. From this project it is concluded that DCM is helpful for separating solid waste from the drainage water, which will further avoid the blockage of drainage line and avoid flooding. 1. Due to continuous rotation of the chain, the lifter timely collects all the waste and thus avoids the blockage by separating solid waste from the liquid. 2. Separation of these solid waste helps in treating the solid waste and thus converting it into degradable waste. 3. Being light in weight, this kind of system can be placed at the junction points of the drainage system that are frequently subjected to blockages. The system functions more effectively during the heavier rains, which has more volume of garbage with high velocity running water through the drainage lines.